We're going to try to get started here. Let me try to get at least my panel under control here. Yeah. Good luck with that. Yeah. Well, thank you very much for still being here at the conference. I think we've got a good closing panel for you to think further about these issues. Actually, we're divided into two basic areas of discussion. I've asked each panelist, exception of one who's joined us on last notice here, which we very much appreciate, to do a brief presentation. And we have something novel for this conference. We actually have some slides, all right? And so we'll go through and we'll comment on that in the first half. Second half, I have a few questions where we're kind of hitting cleanup here on the conference topics and issues. So we're going to cover some of those. And then I'm going to turn it over to you for 15 minutes to raise some questions that you might have from the presentations, obviously, or from the conference in general that you would like to get some reaction from the panelists on. So that's the plan for this panel. I'm going to introduce my panel first here, and just going right down the line here, I've got Gerald Adams, who's the Sharswood Fellow and Resident Scholar with the Center for Technology, Innovation, and Competition at the University of Pennsylvania, Carey Law School. We have Rob Frieden, the Academy and Emeritus Professor of Telecommunications and Law at Penn State University. We have Carolyn Kahn, who has been introduced before, but she's the Distinguished Chief Spectrum Economist at the MITRE Corporation. We have Lynna McGrath, who is the Deputy Associate Administrator for Spectrum Management within the NTIA Office of Spectrum Management, who is the one who subbed in on late notice. So she has the ability to say, hey, I didn't know I signed up for this, and pass. And then we have Scott Palo, who's the Charles Victor Schelke Endowed Professor in the Smead Department of Aerospace Engineering Sciences at CU Boulder. So our final panel here, we're going to be digging a bit deeper into this notion of different frameworks for spectrum management and how they may need to differ between terrestrial and space communication systems. And we're going to investigate this from an interdisciplinary perspective, which is my favorite passion and preferred methodology for investigation. So I do have our anchor, so to speak. Dale Hatfield will recognize this. This is a framework. Dale and I teach a class on spectrum management every Maymester, and there's twofold for that. First is we get a lot of technical engineers who want to understand more about spectrum management. And the second is that we have Hatfield scholars from the law school who are going, well, most of them to Washington, to work at some of the areas that you might be interested in, you know, places like the FCC or the NTIA. And those law school students, this is their first exposure to spectrum management. And so they are spun up and they really hit the ground running. So I'm doing this in part as, you know, to let you know that if you're interested in having law students or other Hatfield scholars, they don't have to be just legal, right, Dale? They can be technical. Talk to Sarah Schnittgard and get on the list, because these students are really energetic and interested in the topic. And we have a 3-week boot camp, and we're covering all topics spectrum management. And the feedback we get is they do hit the ground running. So part of what we cover with the students is to make sure they understand just the basics of spectrum management. And we have 4 fundamental steps here in what we call the spectrum management framework that we work through the course in. And this framework came from Dale, Brian Tremont, and others that have taught the course before I did. But we really try to stress these 4 fundamental steps. Hopefully they look familiar to you for those who are experts. So I don't need to go through and define each one of them. But at the top level, obviously, spectrum allocation is just who gets particular bands. The technical and service rules are really the constraints that are put on it. in terms of how it's used, the spectrum assignment, who gets it, and then the enforcement is without enforcement, what does steps 1 through 3 mean, right? And so I've asked the panelists, some to be cognizant of these categories, because sometimes within these conferences, you get statements that converge various enforcement steps with spectrum allocation decisions. And so I'm trying to use this as a way to help you as a tool to organize your thoughts about, with all these problems or issues that we've covered here within this transition to more usage in space, this is a nice framework to help anchor you on what these different issues imply. So we're going to start with Gerald, and I'll turn it over. 5 minutes.
Thanks, David. So I think just to start, because we're batting cleanup here, just to recognize that this discussion is at least partially emblematic of a broader theme that's been brought forward throughout the last 2 days, which is, this quote is coming from the Financial Times article back in March, essentially recognizing, the commercial space age is here. Commercial filings for lunar spectrum in particular, the context that we're viewing, has surpassed those of space agencies and governments. The figures themselves are a little bit misleading. This is showing cumulative filings, but nonetheless, if you look at the spikes themselves, we see fairly marked jump by commercial actors. And there's at least some projections that these spikes are going to get even more significant. It's going to continue throughout the foreseeable future to the point where we're having hundreds of filings. And so the question is, okay, well, what do those filings actually entail? This is representative of the Commercial Lunar Payload Services Initiative that NASA is doing. So it's somewhat of a public-private partnership. Where exactly are these payloads being placed? I think for our folks on the radio astronomy side, the middle figure is probably slightly concerning. The one I want to emphasize is actually on the South Pole, where this is just providing an indication of commercial operators contracting through NASA, has no discussion of the broader international actors that are also going to try to occupy and use the South Pole for various reasons. And so this is just a tiny sliver of what the actual kind of occupancy and environment is going to look like. Am I quiet? Sure. Yeah, so the question is, okay, well, now that we're in this new arena, it's not necessarily a new problem, but it is a new environment for facing that problem. What do we need to do? And right now, the management regime is a Band-Aid, is the way that I would phrase it, right? So my understanding is most of the operators that have put payloads out on the moon, they're operating under experimental licenses. I know maybe Jennifer will correct me. I think you shot your shot for a blanket license. I don't know how that went. But nonetheless, it's not providing any sort of security of expectations here, right? Like, if we have to continually ask for experimental licenses and waivers, that seems somewhat problematic. There's also the lack of allocations, at least in the bands that folks want to occupy. And so you have everybody operating under 4.4, where it's a non-interference basis. And so we want to try to provide some semblance of security. We want to have some sort of management framework. What does that entail? And I think it gets to the title of our panel, which is extending, right? And there's been some, at least, arguments or proposals that we just take the terrestrial frame and extend it out into space. And so we look at the frequencies themselves. We already have space research frequencies, but nonetheless, they're probably insufficient for commercial operators that want to economize on the antennas and the payloads that they have. It makes a lot of sense. The things they want to use for space-to-Earth operations work for space-to-space operations. We're going to need some updated service rules based on kind of the idiosyncrasies of the environment that it's operating in, right? The path loss environment is somewhat different, but nonetheless, we're kind of pulling the same moves that David recognized at the outset, right? We looked at allocation, we looked to assignment, service rules, and we recognize that because this is use of space and often satellite services, there's a degree of governance involved here, right? This is shared spectrum, so there's some degree of registration both domestically as along with through the ITU, and then a degree of cooperation and coordination between the entities themselves. what I want to get to is a little bit more of the provocative point, which is, you know, that outlines governance. And I think we've done a good job of presenting governance over and over here, but it's a little bit of a hand-wavy theme to just say, you know, we do governance and governance occurs through the ITU. First come, first serve, you have priority, and just make nice with all the people that are ahead of you. I don't know if that necessarily provides the rigor that we're looking for here. And so just using the terrestrial frame as a foil here and looking to space, what we kind of run into, and what I think is the problem from an academic perspective, is on Earth, we kind of have the crutch of what I call Coasium proxies, which really what I'm saying is there's some moderate degree of exclusion that's available, right? Which is, on Earth, we do have sovereign boundaries. There is some degree of exclusion involved because the interference is happening at the receiver, that on a country-by-country basis, there is a little bit of leverage to come up with robust management regimes. And I look to even the US in particular, which is, yes, we have kind of this in the backdrop ITU coordination procedure and regime that's existing. But when people talk about satellite coordination, particularly on the fixed satellite services side, we're talking about the US's regime with the processing rounds and the entire framework for spectrum sharing between systems within a processing round and between multiple processing rounds, right? That is the structure, that is the rigor of what governance actually looks like. But the first step of it is there has to be a defined boundary, and usually that boundary has some degree of exclusion. I don't want to jump ahead of your question, David, but I mean, this is well known, right? Like this is the Elinor Ostrom frame. If you go through the 8 requirements that she has for common pool of resources and governing them, the very first step is clear boundaries, right? The first step is some degree of property on the outside, and then we do the commons on the inside. And so it provides some degree of what I'm saying is a gatekeeper right and an enforcement hook, the thing that we really need for governance. On the moon, we don't have that, right? For the orbits around the moon, we also don't have that. Article 2 is very candid and clear that we don't have appropriation or declarations of sovereignty on the moon. Post Tongassat, whoever brought that up yesterday, right? In theory, we don't have that for orbits around celestial objects either. And so we're kind of missing, I know a lot of people, David Goldman probably isn't here anymore, a lot of satellite operators complain that getting market access in countries is a just horrible pain and frustrating experience, and it's somewhat idiosyncratic and it varies country by country. But it provides a crutch here. Like, the borders are the crutch for our governance regime from Earth to space and space to Earth. And we don't have that in the lunar context. We don't have that in the cislunar context. And so we have to really come up with some sort of more robust, uniform governance regime that actually does the moves rather than just saying we're going to coordinate and hope on best practices and good faith. Maybe I'm wrong. I just don't have a lot of faith that that's sufficient. And so what does that require? Well, it's going to require some degree of consensus. Our hope and dream is that it's something emblematic of multilateralism from the 60s and 70s. I'm not sure that's necessarily going to happen. I wish Kathy was here, but she essentially had said, well, you know, we do pre-coordination. We have things like the Space Frequency Coordination Group. We have these procedures that exist. They're all based on an outdated regime though, right? Like they're all baked on the idea that this is a few nation states engaging in coordination with one another. And that's no longer the world that we live in, which gets back to my first slide. We have a myriad of private actors with various interests that are operating under flags of multitudes of countries that need to have some sense of security of what coordination is going to look like, what governance is going to look like, and whether there's any sort of security of expectation here. And that seems to be markedly lacking at the moment. So that's the work we should be looking towards. Okay. That's the thing we should be trying to fix.
Give you a couple extra minutes. You were on a roll.
Sorry.
Okay. No, it's good. Any comments or reactions from? Yeah, Yeah.
I mean, I'm just thinking with what you're saying with property rights and, you know, do we take space, which is very different, like you pointed out, to on Earth, and define property rights on space, or maybe there's a new model, or the model needs to evolve to fit space?
Yeah, so I think property rights is one form of getting what I'm calling some sort of exclusionary baseline or, you know, boundary regime, right? That would be the traditional economist Demsetzian kind of characterization of how we would go about and do this. I don't know, maybe that's how we structure it, as we essentially establish some quasi-entitlements on the moon or in the orbits around it and then assign folks to them. Or it's just providing a more robust procedure where we're a little more rigid in who's let into the club and who's kept out of it in certain sequences.
Okay.
So I'll dive back in on the spectrum management piece of it. When you started off and you said the commercial operators are all operating on an experimental basis. Well, you go, well, why is that? Well, let's go look at the US regime. Most of the time they're operating in space research, allocations. Historically, those have been federal. Yeah. So you look at what those bands are, they're federal exclusive. So given our frequency management process here in the US, they're operating on an experimental basis. We're seeing that regime change. Space research is not just the purview of governments anymore. It's now becoming the purview of commercial industry. And do we need to look at changing that? And do we, as you said, do we have enough space research allocations to support that? That's a question the ITU is looking to tackle. But then whose spectrum do we take to do that in? And a lot of the times when you see space research allocations, there's also a load of other allocations on there. So you've got all the other federal users doing other sorts of space-based activities or even terrestrial activities that we're trying to coordinate around. So we're kind of looking at that, the world we knew where this was the purview of governments has moved to commercial industry. And then, yeah, you're very much right. How do we change the regulations we have to support the world we're dealing with today?
So Lynna, the reason it's inflexibility is one observation. Is it fair to say it's because it's the most flexible framework that was available that allowed that to happen within the you know, it wasn't necessarily all experimental, it was mission-based or things like that, right? So, but that's what was the path of least resistance.
I think a lot of times you're dealing with companies that are trying to use existing hardware, which is optimized to operate in those bands. And please start, I don't have my table of allocations in front of me. Would someone please find me the non-federal space research allocations? We don't have them. So we have innovative companies trying to do things, and we don't have regulations, and the current setup doesn't fit. So we're trying to fit the square peg into the round hole using the tools we have today.
Okay, all right. So I have another question, and I'll touch back on this a little bit more, but you know, this notion of the commons is something that I think is a key economic characteristic that we haven't talked about so much in the conference so far. We've kind of said we need to have cooperation and things like that, so we'll circle back. But Rob, Nate, can we get a black screen here for you know, and go ahead. Okay.
Thanks, David. I appreciate it. I've got lots of slides. Quite frankly, with the time available, one slide would take the entire time. But I encourage you to take a look at my website. Just research the name, and I've got a wealth of slides, particularly for your students. Speaking of slides, I want to shout out to Dale. I've used his spectrum management slides for decades with attribution, and the fact that I've been able to do that at least speaks to some of the sustainability of the structure. Now I'm going to talk about how the structure is its own worst enemy in a way, but I do want to gently push back at a comment that was mentioned today, that the ITU was, quote, totally irrelevant. I'm going to push back on that and suggest that the ITU, and let's add the United Nations, is at risk of losing legitimacy. And that's already leading to the prospect and the advocacy for a sort of go-it-alone unilateralism. Some scholars have titled that or captioned that, framed that as polycentric governance. And we already can do some sort of a case study in the notion of polycentric governance or unilateralism. And that case study would be on the Artemis Accord, which quite frankly, in conjunction with a subsequent executive order, disassociates the United States officially with the 1979 Moon Agreement. An agreement that, quite frankly, has failed 1979 and has only about 18 accessions, national accessions. The US government officially disassociates with the concept of shared commons, particularly insofar as asteroid prospecting, extraction of resources, and colonization of celestial objects. And that is creating pressure, yet more pressure on the ITU process and the UN process that has as a baseline consensus view of a shared commons, going to your comment about shared commons. Let me suggest this. Let me present you with a worst case scenario, okay? And not to disparage anybody, and I certainly don't want to be flamed on social media by suggesting that space advocacy, which by the way, I had a slide showing Messrs. Musk and Bezos having at it in the court of public opinion and social media, sort of working the refs, in this case, working the FCC refs. But arguably a worst case scenario would be that private ventures ascribing to the move fast and break things credo have lost patience, have lost trust in the status quo, in the ITU process, in the UN process, and they move forward unilaterally, or they create ad hoc affiliations. They have a polycentric view of the world. Let me give you two examples where maybe that wasn't a good idea. Maybe that model isn't so robust and sustainable and something we want to embrace. In 2008, the FCC fined a company called Swarm $900,000, which was a chump change to this startup venture, which, by the way, then sold itself for $524 million to SpaceX, for kind of forgetting to secure launch authority for CubeSats, small satellites. I mean, these things happen, right? Well, there is something to be said for a process where you advance publish your frequency use, advance publish your orbital slot use, advance publish your orbital plane use, put people on notice that that's where you want to be, and engage in coordination. It's a slow process. It's an incremental process. It highlights a 4-year cycle through World Radio conferences for spectrum management, which doesn't work on internet time, admittedly. But put it this way, if you don't know who's operating where, particularly when you've got microsats that are so small that can't necessarily be tracked and monitored, that registry is really, really important. In 2003, Dish was fined $150,000 for failing to move a decommissioned satellite far enough out into a graveyard orbit where it isn't necessarily likely to decay, wobble, and start interfering with the geostationary, geosynchronous orbital slots, or become yet another large piece of space debris. So my view is I appreciate the notion that particularly internet time is fast. 4 years is a long time. Consensus building is tedious and incremental and difficult. But I go back to 2021 when Messrs. Musk and Bezos were working the refs. They were working the FCC, but working within the rubric of the FCC process, which follows and executes the consensus or takes an exception, reservation to the ITU process, they were willing to sort of recognize the legitimacy of the international forum and of the domestic forum, and it was just a question narrowly whether an amendment of your license application shifting your orbital plane usage would put you in the prospect of having to resubmit, or was it just a substantive amendment to your existing application? So in summary, I appreciate that this process is tedious, incremental, slow, and the treaties don't even recognize commercial actors. They are non-enforceable and have all sorts of flaws. Lastly, in the I'll take the license here because we have product placement for silicon Flatirons. And if this were at the Penn State University, that would be beer and not water, just saying. I want to call your attention to my latest product. It's called Dangers from Regulatory Vacuums in Outer, Inner, and Near Space. It's in the current edition of the Journal of Air Law and Commerce. It's tedious. It took a long time. It can take hours to finish one footnote, but that's my contribution to the literature as a retiree. Thank you.
So a question for you then, Rob. You were saying this is a defense for the ITU and the UN. So you're thinking that's reformable, so to speak, for the scalability issues that Gerald's talking about?
I don't know if it's reformable. And I know that you've got treaties that were executed in the 60s, and a lot has changed, and they haven't been able to muster the resources to reach consensus, to build trust, to study and find nothing more than recommendations. So I appreciate that that's a very tall order to reform and move them into internet time. But my concern is consider the alternatives. And the alternatives don't look so swimmingly better in my estimation.
Okay. We'll go, if we can come back on, Nate, and we'll have Carolyn. Carolyn, you ready?
Sure.
Carolyn, do you need to click?
Well, it's been great to be at this conference. Thank you. I'm learning a lot, really enjoying the discussion, and really excited that the students are so involved in asking such great questions. So, we're talking about kind of where we're at, how can, if and how do we apply spectrum management that we use traditionally here on Earth to space, hearing different notions, are there kind of little bandages or tweaks, or do we take, try to fit a square peg into a round hole or vice versa? Or is there something revolutionary versus evolutionary? So these are important questions. How do we, with the treaties and how do we evolve that to be more applicable and productive in space? So some unique qualities that makes space different from spectrum management, the huge amount of distance in space, so could make something like the commons work there because there's just more area. But as there's more objects get into space, that what will that congestion be, and would that still be viable in those types of situations? Also, the frequencies that we need to use it, and how do we work within these long distances with attenuation, latency, those delays, the mobile and dynamic environment we talked about with the LEOs, the lunar orbits, additional space launches, and many more expected. And a big complication is the stakeholders, just compared to traditional spectrum management, where there are, even on Earth, so many different perspectives and points of views that are important, and then it just extrapolates exponentially when we take it to space. So how do we work with other countries? What can be agreed on? What rules will be followed? What won't be? What are the consequences, or how can they be enforced? And then the resource scarcity and how economics can help to allocate the scarce resources. do we make things equitable? Is it first come, first serve? And this is a very competitive environment where there is a lot of interest in being the first mover there. So some highlights with the economics in this space. It is so strategically important. Great power competition, different nations wanting to be that first mover. Although in economics, being a second mover or close follower has its advantages because you learn from the first mover. The first mover may often invest a lot more money in funding, so more expensive, but makes mistakes, so that second mover can leverage what they've learned from the first mover and sometimes capture more of the market, so there's advantages there. These are global markets. The international players, the coordination that's required, I mean, no single nation can do it on its own, because space is everywhere and requires that international coordination. We talked about throughout the conference externalities and space debris, for instance, and so the unintended consequences and how are those dealt with. We need better ways to deal with those externalities, and whether it's policy and rules or incentives or agreements, or kind of how do you take care of the issues after the fact. And then the collective action that's needed across countries, so that we can have these frameworks, and there's so much common interest. So what do we have in common, and what, as Jennifer Manner pointed out, best practices, what best practices can be established and worked toward. How do we want to deal with equitable access? And these are different policy issues and philosophical goals about what countries will have the rights. Do we want to make it equitable versus the first come, first mover advantage? But the first come, first mover, those are the ones that often have the resources to provide the funding to use that first. And then limited flexibility, because it is such huge distances in space, and once decisions are made, and David Goldman talked about it too with even the regulatory process, but decisions are made early on, and a lot of funding and money is invested in it. So then once ready to launch, or even once something is already launched and say the technology changes or things change, there is limited flexibility to adjust as compared to using spectrum on Earth. Economic drivers, new business models, some will be successful, some won't. Learning to see where the funding is and how can we provide the funding. So it's companies, but also governments, different countries. So is there a way to work together to pull some of that funding, the knowledge, the innovation to achieve more and better? What incentives are there, what incentives are needed, and just how it can benefit everybody on Earth, as well as reducing the risks there. In space, so high costs, much more expensive with the big distances. So you do have those significant upfront costs, which often take longer to recoup. And then the greater complexities, increased risks. So spectrum management on Earth is very challenging. On space, even more so.
Thanks, Carolyn. And I'm going to jump in from a moderator's prerogative here on the value of this slide that she's put together for you is that often, as many of you here know, there are calls for regulation, calls for new laws, calls for new treaties. But you need to have a justification for those new rules and regulations. And so this provides a nice list of market failures or regulatory failures, right? One or two things usually is happening there that is causing the problem. And so instead of just a reflexive from a stakeholder perspective saying, we need to regulate this, you can get much more targeted and specific to the exact market failure or regulatory failure that is causing some kind of a harm or your problem, all right? And so I teach an internet policy class, and when I get a question from the student, why do we regulate? Right? You need to break it down and have a good reason that you're just not reflexively trying to regulate everything. So this is a nice slide that you can take to identify what applies and what doesn't apply. So, I took the questions on your. Do you want to react to that at all, or do you?
Yeah, thank you. I mean, this is unknown space, and so I mean, there's legal risk, technology risks. It is truly multidisciplinary, but like, I mean, I do like how you mentioned, the regulatory failures versus the business failures, and are there things that can be done incrementally? So it's not so like, you don't want to put all your eggs in one basket, but kind of maybe experiment or try different approaches and see how they work.
Okay, we'll go on now. Scott, if you want
All right.
to give Scott the
All right, well, thank you,
clicker
David.
remote.
So David said we had 5 slides, so being a good faculty member, I made 10. And I thought what I really wanted to do is get across a couple of key points here, really about aerospace macros, maybe help set the stage. The assumption is everybody knows what's going on with regards to aerospace and dynamics. Before doing that, I wanted to make an unabashed plug for Spectrum X. So if you're not aware of Spectrum X, you can go to spectrumx.org, but we were founded about 4 years ago under the National Science Foundation Spectrum Innovation Initiative, and really focused to be the largest academic hub for technology, economics, and policy around spectrum issues. So I wanted to kind of back up and give sort of a macro view of aerospace to people. Some of you, this may be very familiar. Some of this, maybe you haven't seen much of. But if we start from the surface of the Earth at the bottom here, move up in altitude, really about 100 kilometers is where space starts. And you can see there's a plot in the bottom there, the blue plot. That's atmospheric density. It falls off exponentially, and we talk about being in the vacuum of space, although you really still have atmospheric drag. So above 100 kilometers, we sort of transition into space. We talk about the low Earth orbit regime that you've heard a lot about, where a lot of the near Earth objects are flying. There's a really interesting regime below that, let's say from about 200 to 400 kilometers, called very VLEO, very low Earth orbit, where there's a lot of interest there with hypersonic vehicles and ongoing developments. I know we're talking about lunar, so I'm going to keep moving out, but I just wanted to sort of point out some interesting things. 400 kilometers, you see there, is roughly where the space station and the space shuttle fly. So one of the things that maybe is always assumed, people know something about orbits, right? So I think the point I like to try to make is you can't just drive around in space like you drive your car. You can't go anywhere you want to. You're really constrained by physics. And there's a couple of sort of basic concepts here, right? And the first one here is that your spacecraft typically flies in either an elliptical or a circular orbit. So for the easiest thing to assume is we're flying in a circle. And up at the top left there, you can see the plane of the circle as in the equatorial plane. We refer to that as an equatorial orbit. The middle one is a polar orbit, where that plane of the spacecraft, it's flying over the pole, and then we have inclined orbits on the right. And so a lot of the LEO orbits we've been talking about are these circular orbits, tend to be inclined or polar orbits. So you can think about there's more popular places you want to be where you're operating in space. There's, call it beachfront property as we're going. And down in the lower right over here, you can see on the bottom row, we move from low Earth orbit up in altitude to geostationary orbit. And the key about that is that spacecraft is moving at the same rate as the Earth. So you're staying over the same space in Earth, right? The same geographic location. So these LEO spacecraft, they're orbiting the Earth every 90 minutes. They're coming over. They may be overhead for 5 or 8 minutes, and then they're gone, and then the next one comes over. And so this is not to scale, but it sort of gives you an idea of the orbits with the Earth. The LEO orbits here out to 2,000 kilometers. The GEO orbits, you heard a little bit about graveyard orbit. That's how we dispose of things in GEO. You move them out to super GEO and get them out of the GEO orbit because they don't come back and deorbit into the Earth's atmosphere. The things in Leo, we wait for those to come down and ablate and burn up as they come back into the Earth's atmosphere. I think one of the interesting things to also think about is we don't just fly everywhere in space. We have to think about these other macros. One of the important ones you have to think about is we have radiation belts. We have a natural particle accelerator that makes some of these orbits very challenging to operate in. It causes, spacecraft's upsets and events. It makes those spacecraft very expensive. So you typically see we operate in Leo where we don't have to deal with these things. And then Geo is, out above the, luckily out above the outer belt. And so this, what I wanted to start thinking about here is looking at where the spacecraft are located and thinking about distance as we're talking about, how does distance impact the ability to operate? And then think about distance in terms of something called space loss, right? So space loss is the attenuation you have in your signal over distance. And so you can see as we go from Leo out to MEO and GEO, the difference between Leo and GEO is about 1,000 times of attenuation in terms of space loss, or 30 dB. We go out to the lunar environment, that's at 300,000 kilometers. So we have another 20 dB or a factor of 100 of attenuation. You go out to Mars, depending on where Mars is relative to the Earth, you're somewhere between 50 and 400 million kilometers away. And I think one of the interesting things from the regulatory standpoint is that the ITU defines deep space as any region of distance that's 2 million kilometers or greater from the Earth's surface. So you're thinking about, almost 7 times farther than the Earth-Moon distance before you're getting into deep space. So think about, from a regulatory standpoint, the lunar environment's still in the, near Earth cislunar ecosystem from a regulatory perspective. There's also things to think about, that there are more interesting places to be in space. There are Lagrange points where you want to put your spacecraft in the Earth-Moon system or the Earth-Sun position, because it doesn't take a lot of propulsion to stay there. So again, thing to point out is as we go from low Earth orbit out to the, into the Earth-Moon, Earth-Sun system, there are orbits that are more interest and are more valuable than others. Just something to be taking into account when thinking about where people are going to be operating. And then I think one of the things we haven't talked about at all, something that I'm super excited about and bullish about, I think optical communications are really the place we should be thinking about and heading when we're thinking about operating in cislunar and deep space. There's been a number of great demonstrations. The LLCD demonstrated 622 megabits per second from the moon to the Earth. Now, granted, that was done on a Lincoln Lab budget using superconducting nanowires on the ground, but it shows you the fundamental capability that you can achieve with optical communications, and you have no atmosphere to deal with. So when you're thinking about the future, I think we need to be considering optical communications. And then fundamentally, there's just an eye chart from the Space Development Agency within the DoD, and they're leaning heavily into optical communications for networking of low Earth orbit satellites. And one of the things I don't think David talked about is that all of the SpaceX Starlink spacecraft have optical intersatellite links to connect those spacecraft. So I want to do kind of just a quick flyby and give some context here, and then think about, as we're thinking about the spectrum ecosystem, I think as we think about, back here with the distance and the impact that has, and sort of how we might think about the neighborhoods as we go and what's happening on the lunar surface versus let's say the backhaul links between the Earth and the moon, and as we go farther out.
Panelists, have any comments or reactions?
So I love this slide, and I'll kind of pick on it. One of the things when we start talking about doing lunar is, and we start talking about doing lunar spectrum management, what's the basis of doing spectrum management? Propagation models. Where's the propagation models for lunar? Actually, that's one of the things being developed right now in the ITU.
Where?
The ITU.
Yeah, good.
The ITU is doing it. They're working, and ITS is one of the folks working on developing the P-lunar model. And a lot of this is we're missing, in some cases, the fundamental science to do this right. And we're learning as we go. But these are kind of setting up some of those basic things because we think we know how things are going to operate in space from an RF propagation perspective, but we're not totally sure yet. So we've got a lot of things to learn, and as we go, I think that's going to be having to build into our regulatory models of sometimes we just might not have the right assumptions to start with.
Okay.
No, I think that's exactly right. And it's vital that we have accurate prediction models because it gets back to one of my initial points and what was just presented, which is, some places on the lunar surface are going to be more congested and more compelling than others, right? Think South Pole and all of the bases and other payloads that are going to be placed there. Some orbits are going to be much more compelling than others, specifically the Lagrange points that you point out. And so, the impetus behind what I'm trying to stress here is that it's because of that environment and those characteristics that we need some sort of robust management framework that's embedded around clear, understood technical principles, rather than at least what seems to be kind of the cursory point at the moment, which is, okay, well, we'll just go through ITU coordination procedures and people will figure it out. I'd like to see something a little more formal and robust than just that reliance.
So Scott, can you go to your chart that had the different inclines of the orbits? There was
Encyclopedia Britannica.
Yeah, one of the comments, and I can't remember who it was. I don't know if it was you, Milo, or somebody was talking about maybe there's room for tightening up what the existing allocations are in terms of the orbit, that it's like 6 to 8 degrees or 2 to 4 degrees. Do you see room in kind of, for at least like the LEOs and the GEOs, room for improvement and additional capacity by using, newer technology and being able to tighten that up?
I think when you think about, the spectrum management challenge, I like the term, I don't know if Al, you were the one that talked about it, or, other colleagues, but of electro space, right? Where it's, separating, you can separate things in frequency, you can separate things in time, you can separate things in coding, you can separate things in position, right? If you're thinking about how we manage. And so I guess what you're saying is, can we tighten up the orbital dynamics? You can fly very precise orbits. We do that. I'm not sure how much value that brings to addressing the problem, right? The challenges.
Well, if the problem is overuse or having too much, if you can get a bit more capacity, more spectrum efficiency, then it's something that's useful. The other question I had for you, since you're probably tracking it, is how well, we then had some earlier comments about more and more debris and the different size of the debris. There's a lot more, like over millions of really small particles. And is there research going on that is allowing us to track that better and like with AI and the like, to be able to predict that much more? Is that going to be an area of concern for quite a while yet?
You think about there's the detection, we can use radio, radar or optical techniques to detect those things. There's a limit on how far you can go in terms of, on the radar side, it's just the radar cross-section, how much power you're using, right? At some point, to get the data into your predictive models, you can only get so far down in size. Then you have the problem that you have space weather. So, I talked about, we didn't get into space weather, but that density curve there, it gets really small. It has a huge impact. When we have a solar storm, the atmosphere expands a bit, then the spacecraft aren't where we think they should be based on our basic Keplerian, orbital elements. And now you have to retrack all those things again to find them and get them back into the system. So it's it's just a fundamental challenge of A, having the data, and then B, understanding the physics of the atmosphere well enough and understanding how those physics impact the objects and how and where to find them.
Okay.
So.
Well, we've got 15 minutes here, and I promised that I can go on for a while, and the panelists we can ask each other questions here. But we start with the wiser rule, obviously, and any students that remaining, or Brad, if you see some, I'll let you. I like to. Okay. There's questions.
Hello, John from Capella. So Scott, I want to thank you for hitting on some of the optical stuff that's coming up. But given the fact that the regulations are written very heavily right now in the RF spectrum, but there's not a ton necessarily in the optical realm, where do you see this going as we're about to see a large boom in kind of the optics that are going up into orbit?
Yeah, I mean, I think it's one of the things to think about is, why do we have the regulations in the RF spectrum? And it's to manage interference, right? It's to manage the users so that you're not negatively impacting each other. One of the benefits of optical is just how narrow those beam widths are. And, I think at some point when you get to a sufficient density of optical users, I think it will be something that has to be considered and how we manage that. So I think it is in a near term, I think it's less of an issue than it's going to be downstream. I think there's also a question that I don't know the answer to is, when you have tens of thousands of optical transmitters, how does that affect optical astronomy, right? So there's, I think, some of these things that we're dealing with in the radio spectrum, we can get out in front of them with regards to optical spectrum and how we manage it. So do I have a crisp answer? I don't. I think we're so early in the stages that some of those things I don't think have really been coming to the forefront. It's more about, can we actually make things work in space optically?
And, I just would raise with optical that emerging new technology, it's not just space that, for example, in the broadband deployment area, middle mile is a real problem, and particularly getting permits, because of various regulations about going, over wetlands and the like. And guess what? With an optical middle mile link, you don't need a permit. You need it maybe perhaps where you're locating the facilities on each end, but it really can speed up your ability to deploy on the terrestrially as well. Questions?
I'll ask one. My name is Nicole Ela. I just graduated from law school here, and I worked in the aerospace engineering before law school. I have a question about, in thinking about the future of lunar spectrum management, how would you approach the enforcement of any regulations? With the example of swarm, I remember when that happened when I was working, some of my coworkers looked at what they did and thought, wow, that was terrible. And a few people looked at it and thought that was an insane risk, but it paid off in the form of an acquisition. So thinking that there will always be a certain number of people who are willing to disregard the norms of the regulations, what would you propose for the future of lunar management?
Okay, I'll start. I've thought about that, and I am of two minds. My number one says it's high time that we recognize the stakes of allowing inertia and obsolescence in the space treaties to fester. There are just too many problems. There are chronic problems and there are emerging problems. So either you're going to get serious or you will get serious because there'll be some sort of calamity. And a calamity could be a tragedy of the commons, the so-called Kessler syndrome, where a very expensive satellite becomes inoperative because it collided with space debris, or ASAT, anti-satellite testing technology, the weaponization of outer space. results in a proliferation of space debris. So one scenario is a clarifying moment, a catastrophe, a calamity, forcing the nations of the world to get serious. The alternative is this polycentric necessity is the mother of invention sort of strategy. The problem with that is you get balkanization. You ignore common principles of that were consensus driven, like the commons, and you get first mover advantages. What you're seeing in manganese nodule prospecting may be a good example of, you know, first mover opportunities. How much can you extract without establishing property, dominion, and control? So I'm, as you could see, in favor of the former, but I recognize that, you know, they've had 50 years to get serious about it, and they haven't so far. A viewpoint of, you know, marketplace sort of driven, gold rush, frontier kind of first mover opportunities sounds very compelling, but then the nations of the world, especially the developing nations of the world, will rally against that.
All right, thank you, Nicole. Nicole is actually a graduate of the spectrum management class. We had another question over here. No, okay.
Yes, I would suggest, I think policy research and economic research is needed with technology research and innovation. I mean, policy regulation can innovate along with the technology. And, you know, again, data is helpful. You know, we need the more science and modeling, but we can also model economics, we can model policy, based on data and assumptions. So working together, I think, could help develop a solution for that.
And also, I think you asked one of the fundamental questions, and one of the things that makes this so difficult. The ITU relies on the sovereignty of each nation to handle that enforcement within their own boundaries. What happens when we don't have that? So I'm the engineer, I will defer to the lawyers to solve that problem.
Oh, no, I mean, this was in my slide, right? This is a fundamental problem. I frankly am not sure how to fix it, right? But yes, the crutch we have always had is sovereignty, because the interference occurs at the receiver, right? So we enforce it on the ground based on whatever particular nation wants to do to manage, you know, co-interference between satellite operators. We don't have that luxury here. It becomes significantly more difficult to put a robust, uniform governance regime in place that everyone respects and wants to abide by. That is really, really hard. Right. And I appreciate what Rob's saying. I lack the same amount of faith that I mean, might take it further. I don't think multilateralism is going to be the way forward. I have no faith that it's going to occur. But it becomes concerning, because then you're getting into, you call it polycentrism. I'm going to be even more harsh and say it's borderline attributed lawmaking, right, by private entities engaging with their particular governments to create norms that eventually accumulate into custom. I don't know if we have the time to allow that to occur.
The flip side is balkanization. I mean, it worked for Yugoslavia. Is it going to work for space policy?
Okay, another question.
Thanks for an interesting panel, David. And just because I can, I'll just tell you that I too am a veteran of Dale and Brian Tremont's version of the spectrum class, the Maymester. I want to just, as an engineer, say there are these things called initial conditions. And terrestrially, I have a lot of knowledge about fixed wireless and terrestrial wireless policy and experience, direct experience using it. The thing I also wanted to say about those initial conditions, whether it's terrestrial or orbital, you have a scenario where you're looking at a moving window of spectrum use and policy, and as more use happens, more things occur over time. That was probably one of the most important lessons that the Maymester teaches the students. My question is, and Carolyn sort of started going down that direction, how does data-driven policy and registration systems accomplish the ability to, in some fashion or form, after the initial conditions are sort of established, is there a way to track over time use of spectrum and be more proactive or ex ante in your regulation? It's an open question. We don't know what we don't know, but I figure it's a worthwhile discussion.
Reactions?
Yeah, I mean, I think that would be great to look at the data, and so kind of the policy that's in place, what's worked well, what hasn't worked, what are the externalities, and then leveraging, you know, what's worked well to kind of tweak and try to make things better over time. But then that does get into, you know, operators that have a lot of sunk costs and investment, and, you know, it's not easy to change things up in space, but we can work toward incremental policy improvements with the data, based on data, and, you know, using AI, machine learning to make it easier.
Just one little quick comment.
Very quick.
Ashley mentioned an operational data repository. That's a really great idea. If everybody that's a stakeholder, and if you look at it as a multi-stakeholder opportunity, maybe there's a cost to it, maybe there isn't, but everybody benefits. So the incentives might be there.
Okay, thanks, Dan. Last question.
Hello, I'm Jillian Quigley from Wiley. I saw on one of the earlier slides that there were only a few of the satellite bands represented in the list. So I think it said like X, KU, C-band. Are there certain bands that are better on the moon, and the one, like, which are the ones that we should be using and which are the ones that we shouldn't be using?
Great question. I'm not in Working Party 7B, so I'm kind of pulling secondhand what I've been told. Someone that is probably can tell you better. My understanding is folks want to economize on the bands they're already using with their payloads, right? And so C-band is one, X-band, KU. I think the one that, correct me please, the one that seems the most concerning from an outsider's perspective is, my understanding is the Chinese have proposed using S-band. And that seems very problematic for the radio astronomy folks on the dark side.
Yeah, so it's one of them. The SFCG does have a lunar frequency plan. So that's out there, and a lot of and that is based on using the existing space research allocations. So it's trying to fit this new paradigm into the existing set of regulations. That's another topic of a conversation of if that's a good idea or not, but given that's the current framework we have, that's what it's built on. So most of the world, as noted through SFCG, has adopted it. China is looking to go in a different direction. But everyone's got 4.4 rights, and S-band has all sorts of anyone who has dealt with S-band understands all the issues that come with S-band. And I will not spend talk about how much time we spend doing S-band coordination. But it's one of them of, I think everyone's trying to figure out how do we do this? And it's the last frontier, brave new world, pick whatever favorite sci-fi phrase you want to use to describe this. We're all trying to figure it out, and we're using the frameworks and tools we currently have. And I think the very accurate question is does that make sense for where we're going in the future?
Anybody else? Well, we are just right on time, and I want to make sure you get to lunch here or the other sessions. So please join me in thanking the panel here for some excellent comments.